My name is Yash Gupta, and today I'm going to talk about how to implement middleware for an application built using Azure Functions. Before we move on to the main topic, let me provide a quick introduction on two important topics which are a prerequisite for implementing this solution: serverless and middleware. So, what exactly is serverless architecture? Before you ask, no. Serverless does not mean that applications are now deployed without servers. That's practically impossible. It's simply a development approach that allows you to focus on building your applications while the cloud provider takes care of provisioning and maintaining the servers on which your application will run. In serverless, applications are architected following a modular microservices approach. Different services that make up the whole application are written and deployed as individual blocks of code. Now, let's talk about Azure Functions. Azure Functions is one of the most popular serverless solutions provided by Microsoft Azure that allows you to focus on writing your code without worrying about deploying and maintaining the necessary infrastructure. Azure Functions provide compute on demand service by providing some independent, individual, readily available blocks of code called functions. Different functions can run anytime you need to respond to any critical events. As requests increase, Azure Functions meets the demand with as many resources and functions as required. And as the number of requests fall, any extra resources and applications drop off automatically. Super flexible scaling approach. Azure Functions are best suited for developing small event-based logical components such as sending emails or notifications, performing database cleanups, initiating backups, etc. Now, let's move on to our next topic, which was middleware. In any application, a middleware is a component assembled into the application pipeline to handle requests and responses. We can have multiple middleware components chained next to each other in an application pipeline. Each component chooses whether to pass the request to the next middleware component in the pipeline, and a component can perform work before and after the next component in the pipeline. Now, there might be an obvious question in your mind that what is the use of middleware in Azure serverless architecture? If we talk about Azure Functions, the use of middleware will allow you to react to incoming requests, but also to change the outgoing response before they leave your function app. Middleware also helps avoiding code repetition in MVC structured applications. There might be certain situations where you are repeatedly copying the same code in your MVC application. For example, when you build Azure Functions as an external API, you don't want to expose any information about the inner workings of your API in your response. And this might happen when an exception is thrown and you don't catch it. Therefore, you need to wrap everything in a try-catch and handle those exceptions. Now, obviously, you can make a fancy wrapper for that, but you would still be copying the wrapper everywhere it's required. With middleware, we can wrap the entire functionality within the next method of our middleware, and we can perform a try-catch operation over there, and it will just be required at one place. Some use cases for implementing middleware could be authentication, performing logging, caching, etc. Now, let's talk about the types of execution modes for Azure Functions. Now, Azure Functions can be executed in two different modes of execution: in process and out of process. Execution mode basically decides whether our logic written inside the functions would execute as a part of same host process or as a separate isolated process. While creating an Azure Functions application in in-process mode, the code which we will write in our function app would be executed as a part of the Azure Functions, its own internal runtime process. When an application is created and executed in isolated or out of process mode, the code gets executed as a separate process from the host process. Now, you might be thinking why these execution modes are important to understand when it comes to implementing middleware. As we saw that in-process mode of execution has some limitations. The code inside our function app should target the same framework version as the Azure Functions host runtime process, or else the application won't work as expected. Another thing is we don't have any control over the process startup, configurations, middleware used, etc. The isolated mode of execution gets rid of all these limitations, as our code, which is written inside the function app, will get executed in a totally separate process from the Azure Functions runtime. And in that way, we get control over the process startup and a lot of other things. So basically, middleware implementation is only possible using isolated mode Azure Functions. In the next video, let's head over to Visual Studio to understand how to distinguish between different modes of execution. Thanks for watching.